Question number 5. Again, this is a theoretical background question, so we will move on. Consider the following reaction that is given at temperature 25 degrees Celsius. So AB solid is going to form C solid and B gas. And the following data was given. So enthalpy of this formation of these compounds, the reactant and the products are given, and the entropy is given. Okay, and they show that the reaction is non-spontaneous. So to show a reaction is non-spontaneous, you have to use the reaction delta G theta is equal to delta H minus T delta S for this given reaction. But you don't know delta H or delta S at this point, because you know only delta H for these compounds individually. So what you have to first do, you need to write down this reaction and you need to find delta H theta R is equal to delta H product, delta H theta products minus delta H theta reactants. Okay, because they have given the values. So delta H theta product means you should write delta H theta formation of D gas, that is minus 500. You need to write, okay, minus, then you have delta H theta formation of C solid, which is minus 600. So this will be the product. Minus, then the reactant is AB, so this will be minus 1208. So anyway, this would becomes minus 1100, and this would become plus 1208, and finally I will have the energy change, that is plus 108 kilojoule per mole. Okay, so this is how you find enthalpy. So at the same way you can find entropy. So we have found enthalpy, and at the same way you can find entropy. And when you plug this temperature which is given at 25 degrees as 298 Kelvin here, and you will see delta G is a positive value. Okay, so I will stop screen and we can do this in the board. So basically so this was the reaction. So AB solid gave us like C solid and D gas. So we found enthalpy, delta H theta R was plus 108 kilojoule per mole. So in the same way, you can find delta S theta R. So when you find delta S theta R, it will be, I will tell you the values here. So delta S was 0.12 kilojoule Kelvin per mole. So you have this one. Then you can calculate delta H theta, delta H minus T delta S. So when you calculate this delta G value, you will get 72.2 kilojoule per mole. So this is a positive value. So you can tell, since delta G is positive, the reaction is non-spontaneous for this first question. Okay, so this is the normal way. Delta H here 108, delta S here, temperature is 298 Kelvin. Then you can plug this here and find delta G. It will be 72.2, and you can explain, since delta G is positive, the reaction is non-spontaneous. So this is first step. Okay. In the second, they have mentioned this reaction is spontaneous, when the temperature is greater than T. And this reaction is non-spontaneous when the temperature is less than T. So calculate T. So what it says, so we know delta G is equal to delta H minus T delta S. Okay. This says when the temperature is greater than T degrees Celsius, this is spontaneous. And when the temperature is less than some certain temperature, this is non-spontaneous. At one case, this is spontaneous. At one case, it is non-spontaneous, which gives you the margin where at temperature T, this can be considered as a spontaneous or non-spontaneous in nature. Because they say greater than that becomes spontaneous, less than that becomes non-spontaneous. So this should give you the idea the temperature that we are looking for could be giving a nature of spontaneity and non-spontaneity. And this is like a reaction is in equilibrium where at this point delta G should be around 0, because we can consider delta G when it is more negative, it is spontaneous. When delta G is more positive, it is non-spontaneous. So how we determine delta G positive or negative? Based on the temperature. That is what they have given. At some temperature greater than that, it is spontaneous. Less than that, it is non-spontaneous. So this gives you the idea at this point, delta G is 0 at this temperature. So if this is 0, you can automatically calculate T delta S to be delta H and T to be delta H over delta S. So you know for this reaction, we calculated delta H was 108 kilojoule per mole and delta S was 0.12 kilojoule per Kelvin per mole. So you can calculate the temperature. Okay, so this will be straightforward. And when you calculate the temperature, you can see it will be around 900 Kelvin. Okay, so that is necessarily need to be calculated. So we have done the second part also. So what are the assumptions? So this is important to understand. The first assumption is, think about this. The first assumption is this delta H and delta S were before calculated at temperature 298 Kelvin. Okay, these were calculated at 298 Kelvin. But don't forget, when we apply this equation and find the temperature here, it was 900 Kelvin, where delta G should be almost 0. But think about the enthalpy and entropy value at 900 Kelvin. This will not be same as this delta H and delta S at 298 Kelvin. So there is a problem, because if you want to plug this equation, actually you should know this temperature, what is the enthalpy value and entropy value. But we can't calculate that because we are calculating the temperature. If you know the temperature, what's the point of calculating entropy and enthalpy? We know that. But here we are calculating a temperature. So we need some enthalpy and entropy value. So we think the enthalpy and entropy value that we have calculated at 298 Kelvin remain same in this temperature also. So that is what our assumption is. Okay, so we think the enthalpy and entropy values are same in this temperature as in 298 Kelvin. Okay, so that is the idea. This is what the same idea is. Right. Then we will move on to part B. So this is a normal basic question. Then we have to move to part B. Then they say when the reaction described in A above is carried out in a closed container, so they have given the volume at 930 degrees Celsius, the system reaches equilibrium as below. So we will first write down the information. So the information tells okay. So when this reaction is done in a closed container, so the volume is given to decimeter, temperature is given 930 degrees Celsius, and this reaction is in equilibrium where AB is solid, gives C solid and D gas. I think it was 2D gas. No, just gas. Yeah. Yes, just D gas here. Okay. And they have information, the pressure of the container was found to be 4 into 10 to the power 5. So they have found this pressure of this container, which means the total pressure is 4 into 10 to the power 5 Pascal. Okay. And they have told that calculate Kp and Kc and take RT at this temperature as 10 to the power 4 joule per mole. Okay, so RT at this temperature, they have calculated the rough value and given. So we need to find Kp and Kc. So one thing that you need to identify here, in this equilibrium, the only compound that is in the gaseous state is this one. Okay, so the entire pressure in the system is given only by this D gas. So first thing that you need to identify, PT should be equal to PD gas because this is the only gaseous product. The other two are solids. Okay. So PD is 4 into 10 to the power 5 Pascal. It is same as PT. And then when you write down the Kp equilibrium for this reaction, there is PD gas, there will be no C or there will be no AB because those are solid. So your Kp automatically becomes 4 into 10 to the power 5 Pascal 2. Right? And then you can use Kp equal to KCRT delta N to find Kc, because now Kc will be Kp over RT delta N. Okay. Okay. So the only product that is present here is D gas. So that is the only gaseous product that you have. So the entire total pressure, that is 4 into 10 to the power 5, should be given by D. So this total pressure should be equal to PD gas, which is 4 into 10 to the power 5. And in return, you need to know this Kp expression only will have D gas because C is a solid, AB is a solid. So your Kp expression is this, and surely your Kp value is also 4 into 10 to the power 5 Pascal because that is the only partial pressure that is present. And then you can use this equation to calculate Kc. So Kc will be equal to Kp over RT delta N. So RT value they have given 10 to the power 4 joules. Then delta N is 1 moles plus 1 moles, 2 moles. 2 moles minus 1 means 1 mole. So basically delta N is 2 minus 1, product moles minus reactant moles. So 2 minus 1 is 1. Then you can put here 1 and RT is given. Then Kp you have calculated here and you can find Kc. Okay. So this was the first part of the question. Part B. So in part B, this was the first. State the assumptions that you made. So what are the assumptions here? The main assumption is D act as an ideal gas. So there is one assumption that you can use here, and there is no pressure created by C solid and AB solid. Okay. So this is a normal method. They have made it little bit easier because they also have calculated this RT value, which is 10 to the power 4 joule per mole, right? And in the second one, they say when the above reaction is carried out in the presence of a X gas. Okay, so now what is happening here? The yield of D can be enhanced. Then the system shows a new equilibrium. So here it was AB solid, just giving the equilibrium. And now here there is an X gas that is reacting in order to give you C and 2D. Now this is modified. So I will erase this one to show the new equilibrium in the same container. So we have a new equilibrium, AB solid plus X gas, forming C solid plus 2D gas. So the amount of D formed is enhanced. That is what they have mentioned. Okay. When this reaction is carried out with 2.25 into 10 to the power minus 1 moles of X gas. So basically we use 0.225 moles of X gas in a closed container, so same volume. The partial pressure of D gas found to be 7.5 into 10 to the power 5. So D gas was 7.5 into 10 to the power 5 Pascal. So imagine what is going to happen here. Okay. Calculate Kp and Kc for the new equilibrium. Explain qualitatively the changes that could take place in the equilibrium in part 2b in the following instances. So there's another one. So we will first go with this one. So we have to find Kp and Kc for this new equilibrium. Think about that. So let's think about like this. So initially, there could be like, let's say, A moles of AB. And at equilibrium, this would be like, let's say, reacting X moles for an example. We don't know. So this could be A minus X for AB solid. X will be like 0.225 minus X. And C will be like X forming. And D will be like 2X forming. Okay. This is at equilibrium. Okay. So one thing that you can get directly from this is, you know, the partial pressure of D gas that is given 7.5 into 10 to the power 5. So the stoichiometry is 2:1 according to the number of moles also. So the partial pressure of C gas should be half of this. Okay, partial pressure should be half of this. So it will be 7.5 10 to the power 5 Pascal over 2. This is straightforward. And what about X then? We don't know X. So X means the amount that is formed here, C. We don't know X. We don't know 2X. But we know the partial pressure here. That is important to understand. And to find Kp here, the partial pressure of D and the partial pressure of X both should be known. But I have an advantage because we know the partial pressure of D. So the only thing that I have to know here is the partial pressure of X gas. Okay. But I know how much partial pressure is reduced here. Okay. Because X amount forming here was 7.5 into 10 to the power 5 over 2 Pascal. So how much partial pressure that is going to reduce is same. This is one of the things that I know, because that much of amount is reacted, right? To form this much of amount. Just to imagine. But how can I find this thing at the end of the day? I have an advantage because I know how much X that have been used initially, that is 0.225. Okay, so to find Kp here, my Kp expression will be partial pressure of D gas to the power 2 over partial pressure of X gas. That is important. But I know partial pressure of D gas that they have already given. The only problem is to find partial pressure of X gas. So how can I find? The easiest way is this. So this, since this is a solid, so there will be no pressure here, although we think that according to the stoichiometry 2:1, if this is 7.5, this could be 7.5 into 10 to the power 5 over 2. But here in this case, since this is a solid, there will be no pressure shown by this. Okay, so the only other pressure is shown by this. But how can I calculate this thing? How can I calculate the remaining partial pressure of X gas here? The advantage is I know how much initial that they have used here. And I know the volume of this, the temperature of this, even R is, I know. For X gas, I can apply PV is equal to nRT, and I can find the initial pressure that is exerted by this X gas. In fact, what you can do here is you can apply the PV is equal nRT for the X initially, or either what you can do here is you can apply this PV is equal to nRT for D gas. You have many methods, but you need to find which one is good, because here if you apply this partial pressure, which is you already know, for PV is equal to nRT for D, you know the pressure 7.5 into 10 to the power 5 Pascal. Volume is 2 decimeter. So you need to calculate, you need to convert that into meter cube. So -3. You need to know number of moles of D. RT is 10 to the power 4. So when you calculate N, you will find this N is equal to 0.15 moles. Okay. So here now, you know this 2x now. Because initially we thought that if this is A minus X, this is 0.225 minus X. So minus X is reacting. So X moles of C should form and 2X moles of D should form. And now you know 2X, that is 0.15 mole. Okay. So how much X should be reacting here? 0.225 minus 0.15 divided by 2, because this is 2x. So if this is 0.15, this is 0.15 mole divided by 2, which is x. And here you will have X gas 0.225 minus 0.15 mole by 2. Okay. So now you know the number of moles of X gas as well. So if you know the number of moles of X gas, what you can do is you can directly find the mole fraction, and you can find the partial pressure as well. Because if you know the mole fraction, you know that P total should be equal to the partial pressure of D gas as well as the partial pressure of the X gas. But here you know the partial pressure of D gas here. So we know partial pressure of D gas is equal to mole fraction of D gas times total pressure. Okay. So you know this one. You know this one because you know the number of moles, and you know finally the total number of moles here. It will be this one plus this 0.15, because for partial pressure These two are the only compounds that is necessarily participating, because C and AB are solids. So this becomes straightforward. So you find total pressure, then you subtract 7.5 into 10 to the power 5 to get the partial pressure of X gas. Then you substitute here in the Kp equation to find Kp. Then you use Kp equal to KCRT delta N to find Kc. That is how it goes. Okay. So it is very important to understand that fact. Right. So the next part of this question is you need to tell what is the change when C is changed. So there will be no change of C because C is a solid. So there will be no effect to the equilibrium. Either you remove C or you put C. There is no problem in that. Okay. And the other thing is what you can do is what they are asking is, so when you remove D, what is going to happen? To maintain equilibrium constant, this forward reaction should favor. So the concentration of C will increase. According to the Le principle, when you remove D, the equilibrium should shift in a way as to increase D. So the forward reaction should favor shifting the equilibrium towards the right hand side, making the concentration of C gas increase. Sorry, C solid increase. Okay. So the yield of C increases at that point. Okay, so 1 and 2, you can understand what is going to happen to the equilibrium and the amount of C. Right, so I will right, so then I will share the screen again. So this is the last part. So this says what will happen when you change C or when you remove D. Basically, when you change or remove at C, nothing will happen to the equilibrium because it's a solid. And when you remove D, what will normally happen here is the equilibrium will shift to the right hand side and more D and D will be forming and the yield of C also increasing. So the equilibrium will shift towards the right hand side. Okay. So this is also not a hard question. The only thing that you need to know is the information and the theory that you need to know in a background level. So these are basic things.